Today we are going to discuss about the subject called power electronics. This subject is very important for the GATE exam and ESA exam and all other competitive examinations also. Okay, now the minimum 8 marks will get it for the GATE examination point of view on this subject. Before going to the subject, first concentrate what are the textbooks you need to follow for the power electronics. The first one, the power electronics devices and its applications by M.H. Rashid. The second one, power electronic converters and its applications by Ned Mohan. The third one, the power electronics by P.S. Bimra. These are the very important books we need to follow for any competitive examinations. Now I'm going to discuss about in details about the power electronics. The first one, I'm classifying the electronics into two categories. One is signal electronics and one more is power electronics. What is a signal electronics? You are already studied in your analog circuits, that is the devices which will be operated at signal power. That is, signal is a low power or high power. It is low power. But power electronics, being an electrical engineer, you need to deal with high power applications. Now, this will deal with high power applications. The power is increasing here and the power is decreasing here. Now, what is the basic difference? In the universe, if you are gaining something, you have to lose something. What you are losing here, that is power, but what you are gaining here, power. Now, I want to take it. Here, you are gaining something, that is why you are losing here. Dear students, what you are losing here, it is frequency. But what you are losing here, power. So you need to gain something. What you are gaining, it is frequency you are gaining. What is the signal electronics? The subject deals with low power and high frequency. But whereas the power electronics deals with high power and low frequency. Now to give the clarity, now I want to take it the devices, that is first one, can I discuss about signal diode so that you can understand very clearly. What is a signal diode? Already you are studied in analog electronics. That is anode, this is cathode. Now I have here it is called P and it is N. Now I'm using plus stands for highly doped. There is highly doped P layer and highly doped N layer. It is attached together so that I'm getting a diode that is called signal diode. Now I want to draw the symbol for signal diode, that is this is anode, this is cathode and this is the symbol for signal diode. But I want to take it the power diode. If I am taking a power diode, if I am considering the same thing, what is the basic difference between signal diode and power diode? What is the basic difference? Here it is P plus stands for highly doping, and I'm using N minus, and here I'm using N plus. N plus. Now what is here? Anode, cathode. Now what is here? Highly doped P layer. Minus stands for lightly doped, that is lightly doped N layer, and heavily doped N layer. Now I want to draw the symbol for power diode. It is anode, cathode, and it is a diode. Now I will give the clarity about this one in more detail in the coming lecture. What is the difference between power diode and signal diode? The constructional wise, there is a minor difference. Here there is an N minus layer, but there is no N minus layer here. Okay. Now this N minus layer decides blocking voltage capability. Dear students, I'll explain this point within shortly. And what is N minus layer decides blocking voltage capability. So if the more is the thickness of N minus layer, then more is the blocking voltage capability. Now we discuss about in detail. So I'm expecting a minimum basics from the my students' point of view. What is this one? You know the VA characteristics of a diode, right? What is this one? VA, that is anode to cathode voltage. That is, this is anode current. What is this one? It is minus VAK. That is, what is this one? It is minus IA. Now already you are familiarized with the signal diode. Now how many modes the signal diode can be operated? Two modes. What are the modes? Forward biased, and one more is reverse biased. This is forward biased. This is forward biased. And what is this one? It is reverse biased. What is this one? This is reverse breakdown voltage of my signal diode. Now, sir, today's class I want to discuss not signal diode because the subject is power electronics. So I need to concentrate about power diode. If you take it, the power diode characteristics, that it is almost same as the signal diode characteristics in forward bias. But where you will find out the difference? Where you will find out the difference? The difference you are finding out during reverse blocking, reverse bias characteristics. Now, if you look at, this is reverse breakdown voltage of power diode. Dear students, I'm not finding any difference in the forward bias mode of a signal diode or power diode, where you will find out the difference. The difference I'm finding out during reverse characteristics. Which one will have more breakdown voltage? Which one will have more breakdown voltage? So power diode will have more breakdown voltage. Now, students, by looking at this, is it a practical or idea? Think about it. Now, it is a practical VA characteristics. Okay, if you take it, why it is practical VA characteristics? You have a cut-in voltage here, and you have a leakage currents here. You have a leakage currents. Okay, now till from the last 10 minutes, I'm discussing about all these concepts. But if you look at any competitive examinations, this type of questions they are not asking. What are the questions they're asking on how to answer it? I'll discuss within shortly for you. Now, why power diode will have more breakdown voltage compared to the signal diode? Here, if you take it with respect to power diode, same p plus p plus n plus n plus, but what is not there here and here? What is the thickness? Students, this is, there is a finite value of thickness, but here the thickness is 0. That means if the more the thickness of n minus layer, then more is the blocking voltage capability. Now, what are the questions they are asking and how to answer it? The questions are, what is that? Ideal VA characteristics of diode. Diode means I need to discuss about power diode only. So ideal characteristics of diode. If I'm discussing ideal characteristics, left side they're going to give you the symbols, that is anode, and this is cathode. Now right side there you need to draw the characteristics, very important characteristics. I will tell you. It is IA. What is this one? Minus VAK. What is this one? It is minus IA. Now I want to solve this problem. I want to draw the ideal VA characteristics for that. So the diode, how many modes it can be operated? The diode can be operated 2 modes. What are the modes? One is forward bias and one more is reverse bias. What is forward bias? What is forward bias? Anode is made positive with respect to cathode terminal. Whenever anode is made positive with respect to cathode, then the diode is said to be forward bias. Now, what is the reverse bias? Anode is negative with respect to what? Cathode. Now, students, tell me, what is a, whenever it is diode is said to be forward bias under ideal condition, how it is behaving like? It is behaving like a on switch. What is on? On stands for it will be behaving like a short circuit. Now, what is the voltage across anode and cathode in case of forward bias? What is this? What is anode to cathode voltage is equal to 0. Why it is 0? Because it is behaving like a short circuit. What is the current it is flowing from? It is flowing from anode to cathode, that is IAK. Instead of writing IAK, the anode to cathode, one current it is flowing. So can I call it as it is anode current. What is the current? Anode current. Now, what is the anode current? Is equal to voltage. Ohm's law. Voltage divided by what is the resistance? 0. What is the current it is flowing? What is the current? Infinite. If infinite amount of current is flowing from anode to cathode, then the diode will be short circuit. The diode will be damaged. Why it is damaged? Any diode will not carry infinite amount of current. So in practically, students, you will not directly connecting a diode to a battery. What you will connect? You will connect to some load here. You will connect to some load here. Okay. Now, this what I'm going to discuss. Because if you connect to some load here, then what is happening? Voltage divided by what is this one? Load resistance. Load resistance. Whenever it is load resistance, then this voltage divided by resistance. That means there is a some finite value of current is flowing. So in whenever it is power biased, the voltage will become 0 and current is there is a finite value. Now I need to mark this one. How can I mark this one? If you look at this one, I need to mark voltage should be 0 and current should be, there is a finite value of current. So voltage is 0 and current is, there is a finite value of current. Okay. Any questions? No. Now, now I want to discuss about reverse biased. In a reverse biased mode, how the diode is behaving, how the diode is behaving like. Because whenever diode is reverse biased, students, you know that it is behaving like a open circuit. Okay. It is behaving like a open circuited. Whenever it is open circuited, the current is not allowed. So what is IA? IA will be 0. Okay. Then what is the voltage appearing across anode and cathode? Students, what is anode to cathode voltage? Is equal to minus V. Now, whenever it is diode is reverse biased, the voltage will be minus V, current will be 0. Then, can you locate this one? What is this? If I'm locating this, it will be voltage is minus and current should be 0. Where it is located? It is located on the x-axis. Now, why the gate examiner, ESA examiner, they are concentrating about ideal behavior characteristics? I'll tell you. The number of questions are there on this one only. Now, okay, diode can allow only positive current. Look at this, positive current. And diode can block reverse voltage. It cannot block positive voltage. It cannot allow negative current. Now, if you look at complete operation, okay. Now, you tell me, I want to tell you the bits here. If you take a diode, is a controlled device or uncontrolled device? With respect to principles and operation, it is uncontrolled device. Why it is uncontrolled device? Why it is uncontrolled device? Because the on here, whenever it is power bias, it is on. Whenever it is reverse bias, it is off. The on and off of the diode is not depends upon the internal parameters of the diode. On and off of the diode is depends upon the external parameters. That is, whenever anode is made positive, then diode is on. Whenever anode is negative, diode is off. That is why this device is called as uncontrolled device. Now, coming into the any power electronic device can be operated as only it is a switching operation. Now, according to the switching operation of the diodes are not only diode, any device. First, I'm talking about diode. If you look at the diode, students tell me it is a very important, and from your engineering you know this. Diode is a unidirectional device or bidirectional device? Unidirectional device. Unidirectional device. I'll tell you. Next time. Diode is a unipolar or bipolar. Diode is a unipolar or bipolar. Polar switch. All these are classified based on switching application. Now, look at that. I will explain very clearly here. I will not explain all these things while I'm going with the next of the topics. So, concentrate here only. If you look at here, it is a directional. Direction is indicated for voltage or current. Students, tell me, it is direction is always indicated for current. Polarity. Polarity is always indicated for voltage. Direction for current and polarity is for voltage. Now, instead of calling it as a polarity, can I call it as polar? That is, first five letters of polarity. That is, what is that? Polar. Okay, polar is for voltage and direction is for current. Now, look at principles and operation. How many directions of current it is allowing? Only one direction of current it is allowing. Where it is allowing? It is allowing from anode to cathode. It is not allowing from cathode to anode. So, is it a unidirectional or bidirectional? It is a unidirectional device. Next, if you look at it, whether it is unipolar switch or bipolar switch, how many voltage it is blocking? Blocking, not allowing. Is it blocking any voltage? No, because what is the voltage here? Zero. But how many voltage it is blocking? How many voltages? It is blocking only one voltage. That is nothing but negative voltage is blocking. So, is it unipolar or bipolar? Unipolar. Only one voltage is blocking, that is negative voltage. Now, you are very good students. That is why you know the principles and operation, and you are giving the answers, the gate questions and ESC questions. But I don't want to follow the principles and operation, but I want to get the answers by using some shortcut methods. Now, what are the shortcut methods? What I'm going to discuss to my students. Now, I don't know the principles, what I'm going to do. If you look at ideal characteristics, any device, you need to concentrate about ideal characteristics. If you look at ideal characteristics, how many directions of current it is allowing? One, only one. So, whenever it is like this, is it unidirectional or bidirectional? Unidirectional, only one direction. Suppose if the two directions is there, two y-axis is there, positive and negative y-axis, then it is called bidirectional. Next, how many sides of x-axis is there? Only is on the negative here, negative voltage. Then whenever it is negative is there, then is it unipolar, bipolar? Unipolar. Good. Now, I am not discussed till now about the BJT. Don't confuse whatever I'm discussing the BJT with respect to switching operation point of view. Base, collector, emitter. I'll tell you later. This is also the characteristics if I'm drawing for this plus V plus sign. I'll tell you later, but you need to give me the answers for this. What is this? What is this? If you draw the characteristics of this one, I'll get later, I will explain why the characteristics are like this. Then I will get like this. Then what is the difference between diode and BJT? Same y-axis. Here it is blocking negative voltage, but what it is blocking? It is blocking positive voltage. But BJT, what is this device? BJT, what I'm writing? It is a unidirectional unidirectional device and unipolar switch. It is unidirectional and unipolar switch. Now, it is also unidirectional, unipolar, and like this. Even I can take it. What is that? I can take it MOSFET. Even if I'm taking MOSFET, I will tell you all these devices. If I'm taking like this, gate, drain, source, then the characteristics are coming like this. Then this is also unidirectional, unipolar. That means any device of like this, it is unidirectional and unipolar. After some time, I'm going to discuss about uh, IGBT. IGBT is also, I'll get characteristics like this. That is, it is gate, collector, emitter. The characteristics are like this. Now, I'll tell you what is this device. This is very popular device. Every power electronics engineer will know about this. Anode, cathode, gate. What is this? What is this? SCR. Now, if I'm drawing ideal VI characteristics in the next classes, I'll get the characteristics are like this. Okay. If I'm discussing the characteristics are like this, you tell me what is this one? It is how many voltage it's blocking? Two voltages. How many directions of current is there? One direction. So what I can call it as? What I can call it as? SCR. SCR is a unipolar and unidirectional switch. It is unipolar and unidirectional switch. Now, after some time, I'm going to discuss about the characteristics of some device. I will tell you what device it is. That means I'm drawing all the devices characteristics, but I will not waste the time in the coming classes. What is this one? Minus switch. If the device characteristics of something will be coming like this, that means both the axes are there. There is positive and negative. Then what is this one? Tell me, what is this one? This is a this device is a what direction it is? Bidirectional, bidirectional, and it is unipolar switch. It is a bidirectional and unipolar switch. Now, after some time, I'm going to discuss about what there is a module called track that is MT2, main terminal 2, main terminal 1, and there is a gate terminal. This is called track. Whenever if I am discussing this track, what is this one, sir? Students, tell me, what is this one? This is a bidirectional, and I will change at that time. This is a bipolar. That is bidirectional, bipolar. That means we can take it any power electronic switches. They are classified based on switching operation point of view. It may be bipolar, bidirectional, unipolar, unidirectional, like that. So any device will be comes under this category. Okay. Now concentrate much on this, and so that my job is easy in the next. Okay. Next. Now, students, I'm going to discuss a lot of problems on our different converters. While I'm going for different converters, Students are not concentrating about the device diode reverse recovery characteristics or turn-off characteristics. Without knowing that, you can't study properly about any one of the converter. That is why my humble request for every student is concentrate about reverse, recovery, characteristics, or I can call it as turn-off characteristics. Turn-off characteristics. Turn-off characteristics of diode. What diode? It is because it is a power electronics. Every time diode means assume that it is power diode only, power diode. So only the difference is minor difference in the construction. Whenever it is diode is on, how much current it is carrying? Already I have explained here. How much current it is carrying? Infinite. No. Infinite amount of current is flowing to the diode gets damaged. So how much current it has to carry? Only IA. There is a finite value of current it is flowing. So what is this one? It is, if I'm taking here, it is anode current. What is the current? Anode current. Now how much current it is carrying? IA. IA is limited by load. How much load you are connecting? Based on that, my load IA will be limited. Already told you. Now I want to make it, the diode should be off. How can I make it? Diode should be off. The anode current IA, how much current it is carrying? Anode current. Now I need to stop conducting. How can I stop this is conducting? Can I bring anode current to a zero level? You can use any one of the circuit, external circuit, so that I need to bring the anode current to zero level. It may be a commutation circuit also. Now, how can you bring the anode current to the zero level? By using external circuit. You are thinking that the diode will be stops conducting at this point, but because of minority charge carriers, the current will not, it comes to, the current will comes to zero, but it will not be stops conducting. It goes some point, and after going some point, again slowly it will comes to a minimum value. Already you have studied all these things. Now, what is this point? This point to this point, it is, what is the current here? It is zero. What is the current? I can call it as IRR. What is IRR? What is IRR? That is, IRR is maximum reverse recovery current. There is maximum reverse recovery current. Now, what is this one? It is 25%. No need to take it up to zero value. The minority charge carriers, what is there, it will not comes to zero. What is this one? It is 25% of IRR. Okay, this period is called as, what is this one? It is called TRR. That is, the TRR is nothing but reverse recovery recovery time. There is reverse recovery time, or it is also called as diode turn-off time. But there is a minute difference between diode and SCR. We'll discuss in the next sessions. Now, this TRR can be divided into two parts. One is TE, one more is, this is called TB. Okay, what is TA? TA is nothing but TA is nothing but 0 to, look at this, 0 to the IR. What is this period? During this period, the charge carriers in the depletion layer, whenever you form a PN junction, you have a depletion layer. So in the depletion layer, the, the extra charge carriers are removed during this period. What about TB? The TB is nothing but, here, look at here, IRR2. What is that? That is IRR2. No need to take it IRR to 0, only 25% of IRR. If you take it 25% of IRR, the extra charge carriers near to the depletion layer, here in the depletion layer, here it is near to the depletion layer, can be removed. That is removed. Now, how can you classify the problem? That is nothing but softness factor. That are based on this one only, the diodes are classified. Yes. What is S? It is ratio of TB by TA. Okay. Now, based on this, the diodes are classified three types. That is general purpose diodes, fast recovery diodes, Schottky diodes. Now, I'm not interested in that. Okay. Already you were supposed to study. What is this one? If you look at this, this is very, very important. This. Now, I want to take it. This is the extra charge carriers. This is charge. I want to calculate. It is not a triangle. It is not a triangle. Very important question in your engineering service examinations and your state governments. So it is not a triangle, but can I assume like it is a triangle? If I'm assuming like a triangle, I want to calculate this is a charge, that is Q. How can you calculate the charge? Charge. What is charge of, if you take it, it is a triangle. What is the triangle area? Half into, what is this one? Base. What is the base of this line? Base. What is the base? TRR, half into base into height. What is the height of this? Take it, height of the triangle. What is the height of the triangle? That is I R R. What is Q is equal to half into TRR into IRR. If you know the TRR, if you know the IRR, you can easily calculate the charge. Okay. Now, apart from this, there are some questions. What is this one? How can you bring this one to zero level or up to IRR, maximum reverse recovery current? It is a straight line. Whenever it is a straight line, the slope can be indicated by d by dt of the function. What is a function? It is a current function because it is anode current. Now, can I take it? It is slope d by dt of function. What is that? Di by dt. What is the change here? If you look at di, what is di? Change. What is a change? If you take it from here to here, what is a change? 0 to IRR, what is a change? Can I take it? It is IRR minus 0 divided by what is the change in time? dt. Change in time. What is this one? It is TA. It is 0. Then what is this value? What is this value? TA minus 0. Then what is IRR is equal to, what is that? IRR is equal to, if you cross multiply this one, it is TA into di by dt. But what is TRR? If you look at very carefully, what is TRR? Is equal to TA plus TB. But the TB is the current is coming from IRR2. What is it? IRR2? What is this one? It is 25%. It is almost like a decrease on the line. So if you neglect TB, if you neglect TB, small value, when compared to TA, this can be small. Whenever if it is small when compared to this, then can I approximate TRR is equal to, what is this value? T. Then coming into here, what is this equation? IRR is equal to, what is TA is equal to, what is that? What I have indicated here? It is, what is that? TRR into what? di by dt. di by dt. Now, can I substitute over here? IRR is substituted here. If you substitute it in this equation, then what you are getting, Q is equal to half into, this is already TRR is there, here TRR. Then what is this value? TRR square into di by dt. If you look at so many competitive examinations, they will give what? TRR will be given, di by dt will be given. Can you able to calculate Q? Or TRR is given, IRR is given. Can you able to calculate Q? Or any unknown or charge will be given. TRR is given. I need to find out. This is one more important equation. Then what is the third equation? IRR is equal to TRR into di by dt. Now these three are very important equations. Now students, concentrate here. When the diode can be off, anode current of the diode should comes to 0. But it takes some turn of time. Based on this turn of time, the devices are classified. That is general purpose diodes, general purpose diodes. Next step. Second one, fast recovery diodes. The third one, short key diodes. Okay, short key diodes. These three are very important. Short key diodes. Now we'll discuss more detail about this, but in practically we'll consider TRR. But for all the converters analysis, we are neglecting the TRR is equal to 0. Whenever TRR is equal to 0, when the diode stops conducting, anode current of the diode comes to 0. Okay. The session will be closing now. Better to go to the online test series, the course in aspiringbudget.com. Thank you.